Okay, so this is the revision video, the ultimate revision video for S1. And the first topic that we're going to be having a look at mostly is the regression lines. There's going to be other topics which come in as well, but the regression questions from 2016, 2015, 2014 are the ones we're going to be looking at first of all. Now, one of the things that you need to be aware of is this here. Now, this tells us the correlation and regression. This is in your pink formula booklet, and it's the correlation and regression things, formulae. Now, we're going to be looking at mostly, oh, you can't see them here, but mostly these things here and what they mean, and also the regression model down here. So we're going to get through that. So if we have a look at our first question. We've got a biologist and it's studying the behavior of bees in a hive. Once a bee is located a source of food, it returns to the hive and performs a dance to indicate to the other bees how far away from the source it is. The dance consists of a series of wiggles, so the biologist records the number of distance in meters of the food source from the hive and the average number of wiggles. So if we look into that a little bit more, what we've got is the distance here. Now, depending on the distance, that's how many wiggles. So therefore, this is what the distance is what we call the independent variable, and this one here responds to it. So when it says B, state given a reason, which is the response variable. The response variable is the wiggles, which is W, and that is because that responds. That's independent. It's the it's the distance that determines how many wiggles there are. The number of wiggles doesn't tell you how long it is. It's the other way around. It's the distance which makes the number of wiggles what it is. So here we've got to show that SDW equals 5,601. So if we have a look back here, what we've got to do is find SXY. Now, in the case of our question, X is our first variable, and Y is this one. Remember, X is the explanatory variable, or the independent variable, and Y is the dependent, or the response variable. So SDW is the same as SXY. So if we have a look at that, we've got SXY here, which is this thing here. And if we write that down, it's S, if I do sum of xy minus the sum of x, sum of y, all over n. If we have a look at what that looks like, sum of xy minus the sum of x, sum of y, all divided by n. And notice in your formula book, they've got i's there. Just try and ignore that. So that means the i's just mean the first of the x, the second of the x, the third of the x, all the way up to the nth of the x, which makes it seem a little bit more confusing. All you've got to know is that this is the formula here. Now, in terms of our question, if we substitute x for d and y for w, that's going to be sum of dw minus the sum of d times the sum of w all over n. And then all it is just a matter of plugging these numbers in. So we've got the sum of dw, which we know is 13,833, minus the sum of d, which we're not told, but we can add up what d is, which gives us 1,960, times by the sum of w, which we're told is 33.6, all divided by n. Now, n is the number of pieces of data there are, so that's 1, 2, 3, 4, 5, 6, 7, 8. And if you put that into your calculator, you should get 5601. Now, the next part of the question says, state giving a reason, which is the response variable. And again, like we said earlier, W is the response variable because that depends on the distance. It responds to how far the distance is. Now, calculate the product moment correlation coefficient. Now, this is what we call the PMCC. Now, that is this thing here. It's SXY over the square root of SXX times SYY. And SXX is this thing here, SYY is this thing here, and we've just calculated SXY. But obviously in this case, we're not doing SXY, it's going to be SDW, SDD, SWW. So if we know that it's sxy over the square root of sxx syy. So we know that sxy, or in this case sdw, is that one on top, so it's going to be 5601 over the square root of sdd, which they tell us is this one here, and sww, which is this one here. So 394,600 times by 80.481. And notice that we've got to multiply them both together first, then square root the answer, and then do 5601 divided by that. And if we do that, we should get 0.99389. So what I'd always do is I'd put in a bunch of numbers here and then round it. So they really want you to do it to 3 significant figures. This came out a lot in this mark scheme. So you make sure for stats 1 it's always to 3 significant figures. So put in your whole answer that's on your calculator and round to 3 significant figures. Okay, so that's that one, that one, that one. Now we've got to work out what the regression line is. So the regression line is this one here, y equals a plus bx, where a is this and b is this. So that's sxy over sxx. So if we do that here, sxy we know was 5601, so it's going to be 5601, make that smaller, divided by sxx. So sxx in this question is sdd. So sdd we know is this thing here. So 394,600. And if we do that, 5601 divided by 394,600, we get 0.01419412063. So 3 significant figures, remember, 0.0142. Again, every time you're doing a stats paper, think 3 significant figures. So that's our value of B, if we look at this one here. So now we've got to work out what our value of A is. And A is the average of Y, take away B, times the average of X. Oh, so let's do that. A equals Y bar minus B times X bar. So Y bar, the way we're going to work out Y bar, which in this case is W bar, is you add up W, so you find the sum of W, and then you divide it by 8, because you want to work out what the mean is. So it's going to be 33.6 over 8. And that's going to be the mean of Y. Then what we do is we take away B, which we've just worked out this thing here. Now again, don't use 0.0142, use the whole thing here. So 5601 over 394,600. That way you're not going to lose any marks for accuracy. Times by X bar. Now X bar is the sum of X, or in this case the sum of D, which we worked out earlier as 1960. Divided by 8. And if we do that, it gives us 0.7224, blah, blah, blah. So 3 significant figures every time, 0.722. Now, again, if we go back and we have a look at this, we've got y equals a plus bx. So y equals a plus bx. So if we're going to do it in terms of this question, remember y is w, so it's going to be w equals a, which is this thing here, 0.722, plus b, which is 0.0142, times by x, which we know is d, this variable. That's it. That's what you need to do to get all 4 marks for that one. Now, a new source of food is located 350 meters from the hive. Using your regression equation to estimate the average number of wiggles in the corresponding dance. Now, we've got to use our equation. So, this is the equation that we've just done. And we now know that the distance, so d here, is 350 meters. So all we're going to do is we're going to plug 350 meters into that. So just to make sure that we get our mark for the working, we're going to do W equals 0.722 plus 0.0142 times by 350. And that gives us 5.692. So again, I would always look three significant figures. So 5.69. There you go. That's that one done. Comment giving a reason on the reliability of your estimate. Now, whenever we have these sorts of questions where we've got to work out the regression questions, they always give this. Comment on the reliability of your estimate. Now, what we've done here is we've had a look at 350 and how useful is using our regression line to find something for 350. Now, 350 is a distance, and that lies within 30 to 650. So it's within our data range. So what we need to say there is that it is reliable because it's within our data range. And just in case that leaves any sort of ambiguity, therefore interpolation. So for this question, it's either going to be interpolation or extrapolation. Extrapolation is if they said, use your regression line to work out a distance of, say, 1,350. Now, 1,350 is well outside our data range of 30 to 650. So that would be unreliable because it's well outside the data range. If it's inside the data range, it's what we call interpolation. Outside the data range, extrapolation. I think we should see an example of that in the next question. But yes, that's how to do that sort of question there. Now, let's have a look at the 2015 one and see whether or not that there's any similarities. Okay, so this was a 2015 paper. Statistical models can provide a cheap and quick way to describe a real-world situation. Give 2 other reasons why statistical models are used. Now, I mean, there's a bunch of reasons that you can give here, but you've got to give 2. So one of the reasons that you might want to say is that because you can use them to represent real-world problems. And in doing so, you can change your variables to tests in different conditions. And in doing so, this improves our understanding. So that's 1, 2, 3 different things so far. And also improves our understanding. And if we've got a decent model that's shown it's reliable, we can use that to make, this is a big one, make predictions. So it's not very often this sort of question comes up, but it did come up in 2015. So it's all about understanding why we use statistics in the first place. And these are 4 key things for doing so. Now, let's have a look at this. A scientist wants to develop a model to describe the relationship between average daily temperature X and households' daily consumption Y. So if we have a look here, if we compare it to the last paper, average daily temperature, that's going to be the thing that doesn't change. That's going to be the independent variable. And the energy consumption is going to be the response variable because that responds to the temperature. This changes in relation to this one. A random sample of the average daily temperature and a household's daily energy consumption taken from 10 winter days and shown in this table. Find SXY. Oh, they're using SXY now, so that's kind of nice. So, as we saw before, SXY equals the sum of XY minus the sum of X times by the sum of Y divided by N. So they've rather handily given us a bunch of the data here. So that's going to be the sum of XY is going to be 283.8 minus the sum of X, which, they don't tell us that. So we've got to add up our X values here. that adds up to 12, times by our sum of y, which is 255, divided by our value of n. Now n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there you go. 283.8 minus 12 times 255 divided by 10. And again, if you're doing this as a revision, make sure that you're getting the same answers as I am. And if you do so, what you get is minus 22.2. Okay, so that's SXY. Again, that's the second time we've seen that in the last 2 years. So being able to do this is a key skill. And in terms of predicting what's going to come up, I'd certainly have a look at that. Now, find the equation of the regression line. This always comes up. So find the equation of the regression line. Now, again, if we have a look at our pink formula booklet, we've got our regression line here. So it's y equals a plus bx, where a is that and b is this one here. So let's write that down. So y equals a plus bx. A is y bar minus b times x bar, and b is sxy divided by sxx. Now, sxy, we've already learnt to be that one. So that's going to be minus 22.2 over sxx. Now, sxx is going to be, rewrite it here, sxx. That's going to be the sum of x squared minus the sum of x squared over n. Now, these two things here, the sum of x squared and the sum of x squared, are not the same thing. The sum of x squared means that you square this value, square this value, square this value, and then add them all together. And you're told that's 24.76 minus the sum of x, which we said beforehand was 12, square that, and then divide it by 10. So if we do that, 24.76 minus 144 divided by 10, and we get 10.36. So minus 22.2 divided by that equals minus 15 over 7. Now, again, it's kind of nice, but we could write that out. If we do that to 3 significant figures, again, think about 3 significant figures, minus 2.14. So now we work out what A is. So A is y bar, so that's the sum of y, which is 255 divided by 10. So y bar is the average of y, so you add up all the y's and divide by 10, minus B, which we've got as this thing here, but again, this one here is the real value, so minus 15, let's say real value, the one that's not been rounded. So minus 15 over 7 times by x bar. Now x bar is where you add up all the x's and divide by 10. So that's going to be 12 over 10. And in doing so, we get 28.0 or 20.0714, so 28.1 to 3 significant figures. And then we've got to, oh yeah, because it says, look, here, 3 significant figures. So if we then write it out again, that's going to be y equals 28.1 plus, in fact, b is minus, so that's going to be minus 2.14 times by x. Nice, and that's it, all 4 marks. Now, we've got to give an interpretation of the value of a. So a is this one here. So we've got to give an interpretation of that there. Now, that a is going to be the value when x is 0. So sometimes they ask you to give an interpretation of the gradient, or the thing that's in front of the x. Sometimes they'll give you an interpretation of that one there. Now, that one's when x is 0. So what that means in this case here is when x is 0 is when the temperature is 0. So when the temperature is 0, this is how much y is going to be. Now y is the daily energy consumption. Excuse me. So that means when the temperature is 0, the daily energy consumption is going to be 28.1 kilowatts per hour. So that's what you need to write down. So 28.1 is the Daily is the energy consumption per hour when the temperature is 0. So now estimate her household's daily energy consumption when the daily average daily temperature is 2 degrees. So then what we do is we just use our equation that we've just painstakingly worked out, and we just substitute in the relevant value. So if we write that out, so y equals 28.1 minus 2.14 times by 2, so 28.1 minus 2.14 times by 2, and that is 23.82, which is 23.8. So now the final 2 marks down here. The scientist wants to use a linear regression model to predict a household's energy consumption in the summer. Discuss the reliability of using this model to predict a household's consumption in the summer. Now, if we have a look here, this is the energy consumption in winter. So, discuss reliability. You need to say that it's not reliable. Now, why is it not going to be reliable? In the summer, the average daily temperature is going to be a lot higher, as daily temp, or average daily temp, will be higher. Therefore, out of data range. Therefore, extrapolation. Therefore, not reliable. It's worth repeating it, not reliable. And that's what you need to say. You need to say that it's not reliable, but justify why. Okay, so that was the 2015 paper. So now on the same topic, let's have a look at the 2014 paper. Now this is the 2014 paper. It wasn't the, it's the original one, because they submitted 2 this year for whatever reason. But this is the original one, not the one with the R on it. So we've got, again, same question. So as long as you sort of gone through the first 2 questions of this video, this one should start to make sense now. So here, the table shows data on the number of visitors to the UK each month in their thousands. Now this is, got to be careful with this. Visitors in their thousands and the amount of money spent in millions for each of the 8 months. So 8 months, you've got 1, 2, 3, 4, 5, 6, 7, 8 months. So therefore, n is going to equal 8. So we've got to work out what the PMCC is. Now that's going to come up on another video, but if we have a look at the PMCC, it's SXY over the square root of SXX SYY. So let's go back to this. By the way, we're not looking at this question just yet. We'll have a look at that one a little bit later. So PMCC, which gives us a value R, that's SXY over square root of SXX times by SYY. Now here, that's going to be X, that's going to be Y. The top is almost always X and the bottom is almost always Y. Therefore, we're looking at SXY, it's going to be SVM. The right is a little bit small here, so apologies. 31512.5, so I've written that down right, apart from the decimal point appearing twice. Over the square root of SXX, which in this case is SVV, which we can see is 42587.5 times by SMM, which is 25187.5. Again, make sure that you multiply them together, square root it, and then have the original divided by that, which gives us 0.962. Again, to 3 significant figures. Always think per 3 significant figures. So next one, give a reason to support fitting a regression model to the form m equals a plus bv to this data. Now the reason that we do a regression model, now a regression model, if we think about it, what that is, that's just a line of best fit. So if the data shows that there is a relationship, and it's a strong relationship, then we can do a line of best fit for that. So because here R is very close to 1, therefore there's a strong relationship And again, it doesn't need to be close to 1. It can also be close to -1. But if you've got a strong relation, so strong correlation, either positive or negative, then that is why we do the regression model. So therefore, regression model appropriate. So now we've got to find the value of b, correct 3 decimal places. So b, we know is sxy divided by sxx. So sxy divided by sxx. Let's get rid of this. Bottom of it. So b equals sxy divided by sxx. Now we've done this a few times. We know that x is this one. We know that y is that one. So it's going to be sxy. So that's going to be 31512.5 divided by sxx. sxx in this case is SVV, which is 42587.5, and doing so gives us 0.740. Again, 3 significant figures. Think about 3 significant figures. But now we've got to find the equation of the regression line of m on v. So again, we have a look at our regression line. Y equals a plus bx. We've already got a value of b. So we know that y equals a plus bx. We know that our value of b is this. And a was y bar minus b x bar. So what we've got to do is we've got to work out what our value of x bar is by adding that up and dividing by 10. Y bar by adding that up and divided by 10. And y bar is 1326.25. And x bar is 2423.75. So now we've got that, we need to work out what a is. So a is 1326.25 minus b. Again, rather than using 0.740, use the exact thing here. So 31512.5 over 42587.5 times by x bar, which is 2423.75, and in doing so you get your value of a to be minus 467. So our final answer then, if we then write it down, y equals minus 467 plus b, which is 0.740, times by x. But in this case, sorry, x was v, and we wanted that to be m. So m equals minus 467 plus 0.740 v. Now we've got to work out what our value of b is. So b in this case is our gradient, so 0.740. So that means for every extra v, m goes up by that. So, but what is v? V is the extra 1,000 visitors. So we need to say for every extra 1,000 visitors, the amount spent rose by 0.740 million, or 740,000 pounds would be a better way of putting that. So use your answer to part D to estimate the amount of money spent when the number of visitors to the UK is 2.5 million. So 2.5 million, that's going to be 2,500,000. Let's write that a little bit better. So therefore, V equals 2,500. And again, that's the key thing to this. remember this, you don't substitute 2,500,000 in there. It's got to be 2,500,000. So substituting that into this, what we get is, so m equals minus 467 plus 0.740 times by 2,500. If we do so, we get 1383. Now remember, that's million. So we can stick a bunch more zeros on the end of that. So either 1,383 million or that one there. Comment on the reliability of your estimate in part F. Give a reason for your answer. So again, it's exactly the same as the previous two papers. So we have a look. So our value of V was 2,500, which lies in between our data set, because our data set went up to 2,540 and went down to 2,290, so it lies within the data set. So I would say for this one here, it is reliable. 2,500 lies within the data range, therefore interpolation. And there you go. Well done if you managed to make it through to the end. And good luck on Wednesday.